So let's continue on. We were finishing 14 in section, was it 14 or 17? I think we did 17, so let me mark that off. Now we're to 21. So 21 and 24 are similar to what we just did. They are proportions, but we're actually supposed to solve for x. So we have 21 is 3x minus 2 all divided by 5 is equal to 6x minus 5 divided by 11. So what is the value of x? So this proportion is true such that the ratios, these two ratios are equal to each other. So if you remember, to show whether a proportion was true or not, we cross-multiplied, taking the numerator times the opposite denominator, and so forth. So in this case, we get 3x minus 2 times 11, 3x minus 2 times 11, and 6x minus 5 times 5. We want to multiply this out to unsimplify it. So we take 11 times 3x. 3 times 11 is 33, so we get 33x. 11 times negative 2 is negative 22. Likewise, 5 times 6 is 30, so I get 30x. 5 times negative 5 is negative 25. So we just have an algebraic equation, one variable. We want to get all the variables stuff over here, all the constant stuff over there. So to get the variable stuff to the left-hand side, we subtract 30x. And to get all the number stuff, we add 22. So 33 minus 30 is 3. This goes to 0. This goes to 0. Negative 25 plus 22 is negative 3. Divide by 3 to solve for x. We get x is negative 1. If I plug negative 1 in here, you'll find out that the ratio is the same. That's basically what we're doing. So just to, this will prove that we are either right or wrong. So we get negative 3 minus 2 over 5. And then we get negative 6 minus 5. And I've got parentheses missing. I guess we don't need this parenthesis here. Okay. So you get negative 5 divided by 5 is equal to negative 11 divided by 11. Or negative 1 equals negative 1, which is true. So that's what this whole procedure here does. It's saying what value of x makes it so this equality that involves this associated with proportions is true. Okay, so we do the same thing to the next problem, which is 24. So 24, you get 2x plus 7, all thing divided by 3, x minus 1 divided by 4. So cross multiply 4. I'm going to put the constant in front this time just to be different. Likewise here, I'll get 3 times x minus 1. And the reason I put the parentheses here is to make sure I remember to multiply both terms by 4. If I didn't include the parenthesis, if I just did this, then I might just multiply this term, first term, by 4. But when I'm doing this cross multiplication, I have to multiply the whole thing times 4 and this whole thing times 3 to be correct. Okay, so now we're going to multiply 4 times 2, which is 8. So we get 8x. 4 times negative 7 is negative 28. 3 times x is 3x. 3 times negative 1 is negative 3. I'm going to subtract 3x from both sides to get all the variable terms on the left. I'm going to add 28 to get all the constant terms on the right. 8 minus 3 is 5. Negative 28 plus 28 is 0. 3x minus 3x is 0. Negative 3 plus 28 is 25. I divide both sides by 5. I get 1x is equal to 5. And it's not what the answer is in the book. So what did I do wrong? Oh, I made an error. Okay, sorry about that. So it should be plus 7, but I did minus 7. Don't know why. Okay, let's try it again. 8x plus 28 equals 3x minus 1. Okay, we're going to negative 3x. We're going to subtract 28. Oh, that's made another mistake there. 3 times negative 1 is negative 3. Okay, now we're going to go 8 minus 3 is 5. So I get 5x. This goes to 0. This goes to 0. Negative 3 minus 28 is negative 31. Again, what's happening here is we're on the number line. We start at negative 3. We move to the left 28 units. That brings us to negative 31. So when you start with a negative number and you subtract, you should be even more negative than both of those, which I am, negative 31. Okay, now we divide both sides by 5. And we get x is equal to negative 31 fifths. That's the value of x. If I plug in there, I'll get the proportion to be true. Okay, what do we got next? 25. So 25 is some simple problems that involve proportions. And there's usually two ways to do these. What you have to do is you have to either have something like this where you have two things that are the same type compared to two things that are the same type. Or you have to do something like this. Like that. So the proportion has to have the corresponding same quantities as ratios, or you have to have the same quantities in the numerator and the same quantities in the denominator. I'm just going to demonstrate how that works out with this problem 25. So you've got candy bars. So what you do is you say 16 candy bars is to $20 as, well, I've got the candy bars in the numerator and dollars in the denominator. So the question is, how much is cost for a different number of candy bars? So I've got candy bars in the numerator, money in the denominator. So that's the proportion I set up. But I could also set it up as candy bars to candy bars is money to money. So those are the two ways. Candy bars to candy bars, money money, or candy bars money. And each one is matched up. So the 16 is matched up with $24. 16 is matched up with $24. Now what will happen is you can see when I cross multiply, I'll get 16x is equal to $20 times 24. When I do this, I get 16x is equal to $20 times 24. So when I do the cross multiplication, no matter which way I set this up, I get the same resulting equation to solve. So 20 times 24 is going to be 480, I think. 480. So I get 16x is equal to 480. Divide both sides by 16. 480 divided by 16 is 30. So what I'm looking for here is dollars, so let's put the answer in dollars. So if 16 candy bars cost $20, 24 candy bars cost $30. Now I could put dollars in here. I could put candy bars. But sometimes it's easier just to leave the units off and then at the end go back to the original problem and say, you know, what was I talking about here? Okay, so let's do another one of these, 28. And again, I'm only going to do it one way. So 4 tires cost $398. Okay, so what else do they give us? 7 is tires. So tires is in the numerator. Dollars is in the denominator. Again, I could also do 4 over 7 equals 398 over x. Either way. So cross multiply, you get 4x is equal to 7 times 398. 4x is equal to is equal to 2,786. So divide both sides by 4 to solve for x, and I get $696.50. Make sure your final answer has the correct units. Do one more here. 33. Distance between cities. Distance between Kansas City, Missouri, and Denver is 600. 600 miles. On a certain wall map, this is represented by a length of 2.4 feet. On the map, how many feet would there be between Memphis and Philadelphia, where the actual cities are 1,000 miles apart? So you can see, you know, I have another proportion, got another fraction, and the question is, 1,000. Do I put that here or do I put it here? Well, you put it in the same position, relatively speaking, as you did over here. So the miles are in the numerator. The miles have to be in the numerator here. Again, we could also do 600 is to 1,000 as 2.4 is to x. And here what you're doing is you're matching up the initial pair with the final pair. So the unknown is what is the actual distance on the map for the other spacings. So you cross multiply. 1,000 times 2.4 is 2,400. Divide both sides by 600. Solve for x. X equals 4. And the units were feet.